Hello my friends, in today's video we will be solving the hardest easy geometry problem, also known as Langlei's adventitious angles. So, suppose we have this isosceles triangle with the base angles both equal to 80 degrees and the remaining apex angle 20 degrees. We form segment BE such that it divides one of the base angles into 20 and 60 degrees. Then form CD such that it divides the other base angle into 30 and 50 degrees. Construct DE, and the question is to find the yellow angle. So, first thing we do is we remove some lines which will be unnecessary for us. Then we zoom in order to see more clearly. If we observe the white triangle, the sum of its angles is 180 degrees, therefore we can find the remaining angle. Now, because two of its angles are both equal to 50 degrees, we conclude that this triangle is isosceles. Now, crucial for solving this problem is to observe that the yellow and the green angles seem to be equal to each other. In situations like that, where we try to prove that two angles are equal, there is a general method which can be applied, and I will share it with you straight away. Suppose we have a circle with two equal chords on it. Then we choose two random points on the circle, connect the endpoint of the chords with these white points, and then the yellow and the blue angles will be equal to each other because they intercept equal chords. Now, this is very useful because these two equal angles have vertex points in completely different positions, and they also open up in different directions, but nevertheless they are both equal to each other just because they intercept equal chords. So, how can we apply this useful theorem in our original problem? Let's see. We construct the circumcircle of triangle EDC. This circle meets with segment BE at point F. We form DF, and the objective becomes to somehow prove that the two white lines are equal to each other. If we manage to do that, then obviously the green and the yellow angles will be equal to each other because they will be intercepting equal chords. So for us, the objective becomes to prove that this white triangle is isosceles. I have shared a method on how to prove a triangle is isosceles on a previous video. I will put a link on the top right corner for anyone who would like to see. But the main idea is to form this altitude dg and somehow try to prove that apart from altitude it's also a median. If we manage to do that, then dg will be a perpendicular bisector of FE, and because of that, point D will be equidistant from the endpoints of FE, and therefore DF will be equal to DE, and we will have proven what we need. So, how to do that? If we notice the purple and the green angles, they both intercept the same arc DE. Therefore, they must be equal to each other. Now, focusing our attention on the white triangle, we can see that it's a right triangle with one of its angles 30 degrees. Therefore, according to a geometric theorem, the hypotenuse DF is double the segment DG. Now, from point G, we extend the segment DG until a point H such that DG is equal to GH. Now, because DF is equal to 2 times DG, DF will be equal to DG plus GH, and so DF will be equal to DH. Now, we form the segment FH and we focus on this white triangle. We have that the blue line is a perpendicular bisector of DH. Therefore, point F must be equidistant from the endpoints of DH, and so DF will be equal to HF. Therefore, DF will be equal to DH, which is equal to HF, and so the white triangle is equilateral. Because of that, each of its angles must be 60 degrees. Now, we note that the angle EBC is equal to 60 because we will be needing that later. And we form the segment BH, which intersect DC at point I. Now, if we observe, the blue line is a perpendicular bisector to the green line. Therefore, point B will be equidistant from the endpoints of the green line. And because of that, the two white lines will be equal to each other. Now, if we focus on the two white triangles, we have that BD is equal to BH, DF is equal to HF, and segment FB is a common segment of these triangles. Therefore, according to side-side-side theorem, these two triangles are equal. And because of that, the corresponding angles must also be equal. Now, we noted that the angle EBC is equal to 60 degrees. Therefore, the remaining angle must be 40 degrees. If we remove segment BF, the angle DBH will be 20 plus 20, 40 degrees. We form HC and observe the two white triangles. They have BD equal to BC, BH common segment to both triangles, and the included angles are also equal. Each of them is 40 degrees. Because of that, using side angle side theorem, these two triangles are equal, and so DH equals to HC. Now, if we observe these three white lines, we will notice that point H is equidistant from 3 points which lie on the circle. Therefore, according to a geometric theorem, point H must be the center of this circle. Now, this blue line passes through the center and is perpendicular to the white line. Therefore, it must cut this white line in half. And so we have GF equal to GE. Finally, if we focus on the two small white triangles, we have that GF equal to GE, GD is common segment to both the triangles, and the included angles are also equal. Each of them is 90 degrees. Again, using side-angle-side theorem, these two triangles are equal, and therefore the yellow angle must be 30 degrees. And so we found angle DEB 30 degrees. This was the proof. Thank you for watching this video, and I will see you on the next one. Take care.